So this is our last question of chapter number 27. Is my voice clearly audible to all?
Yes, doctor.
Okay, great. Okay. Could you please just read the question as well as just to see the picture, my dear? So in this picture, we have two batteries, and battery 1 and battery 2, and we connected two resistance R1 and R2. First of all, better we just write all the things what is given in the question. The battery EMF 1, that means the first battery EMF is given as 12-volt battery, and the second battery EMF is given as a 4-volt battery. And then the resistor 1, R1 value is given as a 4 ohm, and R2 value is given as a 8 ohm. So these are all the information given in the question, and this question has maybe more than 5 questions you have here, 5, 6, 7 questions you have here. So my dear, again I have to recall the voltage rule. The first of all you have to see the picture, and you have to confirm whether the picture is closed loop or not. So according to the picture what is given in the slides, it's exactly closed loop. You can see the battery is connected with the resistor 2, and the resistor 2 is connected with the resistor 1, and resistor 1 is connected with the battery 2, and then battery 2 is connected with battery 1. That means the circuit was completely closed. So when you apply the voltage rule, first of all you have to see the strength of the batteries. So we have two batteries. So listen my dear, our first battery is the strongest one, 12 volt, but our second battery is only 4 volt. So what I have to do, I have to consider the direction of the flow of the current in this direction. Clear? Clear my dear? Understand?
Yes, doctor.
Okay, so that means this current is entering R2, this current is entering R1, and at the same time, the current from the battery 2 is against the direction of the current in battery 1, battery 2. You can see better, I can make another color. So this is the current from battery 2. That means this is the current from the battery 2, but the main current we have to consider as from the strongest one. So our strongest battery here is exactly battery 1. Am I right? So we have to frame the equation only from the battery 1. So what I told you, when you apply the rule properly, first you have to separate the battery EMF, and then second you have to separate in the right hand side of the equation, you have to separate the current with its resistance. So that means this current is entering R2, this current is entering R1. So how you have to write, my dear? My first battery is the strongest one. So I have to write the equation E1, that means EMF of the first battery minus EMF of the second battery. Why? Because the direction of the current from the second battery is against the direction of the current of the battery 1. That's what I put minus, which is exactly equal to this current is entering R2. So I multiply by R2, and at the same time this current is entering R1 plus I multiply by R1. That's it. Apart from that, we don't have anything in this picture. We have two batteries and we have two resistors. So now we have to see what are the things we are going to find. So in the first question, we are going to find the current, and then second question, we are going to find the dissipation rate. My dear, what is the dissipation rate, my dear? What's the meaning for dissipation rate? I already told you in the previous
Power.
section, previous power. Very good. That means first, after you find the current, then you have to find the dissipation rate, power for the resistor 1, power for the resistor 2, and also you have to find the energy transfer related, energy transfer rate. You have to see, my dear, again the word rate is coming. So you have to find the power related with the battery 1, power related with the battery 2. So you have two types of power. One is the power related with the resistors, and the second one is the power related with the batteries. And we already know three formulas. What are the three formulas, my dear? P, which is equal to I multiply by V, P, which is equal to I square multiply by R, and P, which is equal to V square divided by R. My dear, wherever you get V, then in this place you have to apply the EMF of the battery. You should not use the letter V. The unit for the EMF is volt. So when you use this E here, P, which is equal to I multiply by EMF, and likewise here P, which is equal to EMF square over R. So these are the three formulas we already studied in the previous chapter. So for today, this question we are going to, for today question, we are going to use this formula for 4 questions, so subdivisions. We have 4 subdivisions. The first one, what is the current for the resistor 1? What is the power for the resistor 1? what is the power for the resistor 2. So before you find the power, first of all, we have to find the current, because current is very, very important. You have to see the picture. So you have to see the equation. We have the current. So first of all, I'm going to use this equation for finding the current. So here our current is a common. So I have to take the current as a common parameter. I multiply by R2 plus R1, and the left hand side EMF1 minus EMF2. So now we have to find the current for the first question. So better I can make A. So therefore, my current, which is exactly equal to EMF1 minus EMF2 divided by R2 plus R1. Now directly substitute the values of the battery EMF. 12 volt battery minus 4 volt battery divided by R1 plus R2. That means a 4 plus 8. Could you please tell me the answer, my dear? That will be the answer for the first question. 12 minus 4, which is nothing but 8 divided by 12. And the unit will be exactly ampere. So could you please tell me the answer for this?
0.667.
Oh, 0.667, and the unit for the current is ampere. So once we find the current, we have to find the current rate. That means the power for the resistors. So my dear, you have to see these three formulas. The current with the resistors, we have only this one. Am I right? Am I right or not? Am I right?
Yes.
So we have
Yes,
to
yes.
use this formula for the second part. What is our second part? For the resistors 1. So that means the power calculation for resistor 1. So what I'm going to do, I'm going to write this formula P, which is equal to I square multiplied by R1. So I value just before we find 0.667, the whole square multiplied by our R1 value is 4 ohm. So could you please tell me the answer?
1.78.
1.78, and the unit for
Watt.
the power is watt. And likewise, you have to find the same dissipation rate for the resistors too. So that will be your third question. So power for resistor 2. I have to use the same formula, but in place of R1, what I have to do? I have to use R2. Power P, which is equal to I square multiplied by R2, and I value just before we found the value 0.667, the whole square multiplied by our value of the R2 is 8 ohm, and that will be the answer for the third question. Could you please tell me the answer?
3.56.
3.56 watt. Am I
Watt.
right?
Yeah.
3.56 watt. So this will be the answer for the third question. And what should be the fourth question? Energy transfer rate related with the battery 1. So what you have to do, we have to use the battery formula. My dear, listen carefully. We can't use this one because here the battery EMF with the resistor is here. But when you just see this formula, we have the current and the battery EMF. That means the battery 1 have the EMF 1 and the battery 2 have EMF 2. So what I'm going to do for finding the D question, what I'm going to do, I'm going to find the power for power P, which is equal to I multiply by the battery 1
Doctor,
EMF. Yes.
why we cannot use the V square over R?
Why we have to use the, because they are related, they are asking about the battery 1. Is there any EMF in here? Is there any EMF here?
No, Doctor.
Clear? Understand?
Mhm.
Because
Yes,
we
yes.
need the current for finding the EMF. Because they did not
Ah.
mention you have to find the EMF for power for the resistors. They ask the power related for the EMF with respect to the current.
Current.
Clear?
Okay, yes, yes.
So that's what I'm using this. So we know the for current value 0.667, and the battery 1 value is given as 12 volt. So 0.667 multiplied by 12. What will be the answer, my dear?
8.004.
0.004, and the unit is watt. And likewise, you have to find A, B, C, D, E. So again, you have to find the same power for the second battery. I have to use the same formula, current multiplied by the EMF of the second battery. So I have to write the current value 0.667 multiplied by my second battery value is 4. And please tell me the answer, my dear.
2.67.
2.67 watt. My dear, 5 questions we solved, but the last 2 questions is related with the theoretical question. What they ask in the last question is energy being supplied or observed by battery 1 or is energy being supplied or absorbed by battery 2? So they are asking whether the battery 1 is supplying the energy or absorbing the energy, or battery 2 is supplying the energy or absorb the energy. This is the question. So according to the question, you have to see our first battery has the strongest value. So that means whatever the battery is the strongest one, that battery is going to supply the energy. Am I right or not? Because we are using the current from the first battery. Am I right? Am I right or not?
Yes, yes.
Why? Because this is the strongest one. The weakest battery, we will never use the current. So according to the question, according to the picture, we have the first battery which has the value of 12 volt, which is used for supplying the current. That means supplying the energy to the entire circuit. And what should be the value for the second battery? Whenever the first battery is supplying and your second battery is absorb the energy. Clear? Clear, my dear? So you have to see here, this current we are just using for the entire circuit, but we never use this value, am I right? So when the first battery is giving the energy here, what will happen? Its positive terminal is connected with the positive terminal. What will happen? So the energy supplied by the first battery should be absorbed by the second battery. So what should be the answer for your sixth question, my dear? A, B, C, D, E, F. What should be the value for the sixth question? The energy is supplied by first battery. And what's the answer for the last one? What's the answer for the last one? The energy is
Absorbed by second battery.
absorbed by second battery. My dear, I hope everybody we have the car. Am I right? Am I right or not? Most of the students we have the car. My dear, sometimes if your battery is drained on the way, what you will do? We have the jumper wire and we just call another car and we connected the jumper wire with the battery positive to the another battery positive. Am I right? Am I right or not? For example, my car has the weaker, my car has the weak battery. For example, your car has the strongest battery. So now I want to start my car. So I have to take the energy from your battery. Am I right? Am I right or not? So what we have to do? We have to connect the positive terminal with the positive terminal, and we have to connect the negative terminal with the negative terminal. Am I right? And then the strongest battery has to turn on the car, and the energy from the first battery should be given to the second battery. Am I right?
Yes, yes.
Am I right?
From the
So
strongest
that
to
means
the weakest.
the energy is taken from the strongest battery. Am I right? And the energy is absorbed by the weakest battery. Am I right?
Yes, yes.
So that things exactly we are just using this concept for our day-to-day life application. Understand? Clear?
Yes, doctor. Doctor, can you
That's
please go to the next page?
My handwriting was very bad. Please, my dear, because this is observed. Okay, this is A B S O R B E D, and this one is supplied because the first battery is going to supply the energy. The second battery is going to absorb the energy. Clear?
Yes,
Clear?
doctor. Clear.
That's it, my dear. Actually, this chapter was over. And the most important thing, I have to again to remind you about your assignment 2. Please try to submit your assignment 2 in this Thursday. In this week, you have to submit. My dear, those who are coming far away, please just after you complete the assignment, please give your assignment paper to your friend to submit on my table. And I have to grade the paper and I have to enter the marks immediately in the SIS. Yes, Brother Jawad.
Doctor, I have a question.
Yes.
I have a class with you, the practical at 12:55, but I don't know what's the room number because you told us
just come, my dear. You can find either you can find me either in room number 120 or 118. It's the next room.
Okay.
120 or 118. I will be in any one of these room. Okay.
Okay, doctor.
Just come. This experiment was very easy. You will finish that experiment very quickly. Clear? So please, my dear. Yes.
Do you hear me?
Yes, I hear you.
On Thursday, when we submit the assignments, the time?
My dear, if you submit in the morning time, that will be good because afternoon I have a preparatory class, then I will leave. Better submit the paper before 12 o'clock.
Okay.
Clear? That will be that will be good because I will collect all your paper, I will grade, and I will enter the marks in the weekend. And after that you have the vacation, and it will be really very, because sometimes if you miss, then immediately I will enter the marks. And after that, please don't come and ask for the mark. That's what I said. I gave the question earlier, and you have 4 days, 5 days for solving, and that question is not worth for 5 days, my dear. If you sit for half an hour, you will complete that question quickly. And all the
Doctor,
questions are one. Yes.
if I don't, Doctor, see you in the class, in the room, can I
Just put my
submit the assignment there?
just put your paper on my table. No need to wait for me.
Okay.
Just come to my office. You know my location. Am I right? You
Yes,
know my
yes.
office location. Am I? Just put your paper on my table. No need to wait for me, my dear. It's my kind request. No need to wait for me. Just come and put your paper on my table. I
Okay.
will collect all the paper. Suppose if I miss anything, inshallah, for sure I will ask you. Don't worry.
Okay.
Clear? Clear, my
Clear.
dear?
Yes.
That's it, brother. I think the class is over, because after that you have a what is that? After that you have the lab classes. Some students, you have the lab classes, so better we leave the classroom, because it will be real, because only 5 minutes break for the period 3 and period 4.
So can I leave,
So it will
Doctor?
be real. Yes, brother, you can leave now. Please come safe.
Thank you.
And we are going to do our 9th experiment today. Okay, come safe. Assalamu alaikum.